Hi, it's Tom, and today we are going to solve another very popular coding interview problem. As usually, we are using lead code, so let's go to the problem. The problem is called longest palindromic substring. So the problem is, given a string s, find the longest palindromic substring in s. You may assume that the maximum length of s is 1000. So this problem has a lot of possible solutions. As usually, I will show you two. The first one is the brute force, and the second one, which is much more optimized. Well, in general, that's one of the best possible solutions for this problem. Okay, so let's switch to the whiteboard, and I will show you exactly what are the two solutions. Okay, so we are already on the whiteboard. I prepared a string, which will be our test case. It's cccaba. I selected this particular string because it will make easier to understand, especially the second solution. But let's start with the brute force. So the first idea which may come to your mind is to check all possible substrings of s. And that's exactly the brute force method. So we'll start with the first character c, and in this step we will check all substrings starting with c. So it will be c, cc, yeah, so we have all substrings starting with the first character. And as you see, the first is palindrome, the second is palindrome, the third is palindrome, others are not. So yeah, we have the longest palindrome, which is ccc. So we can go to the second step, where we start with second c and create all possible substrings from this position. So it's c, cc, cca, ccab, ccaba. As you see, only those two are palindromes, but neither of them is longer than the first one. And as you see, that's just the rule. We have to go through all characters and create all possible substrings. It's a very inefficient method, however, it works. And yeah, that's it. That's the simplest solution. And maybe let's switch to the Xcode, to the VS Code, sorry, and check how this kind of solution may look like. Okay, we are in VS Code. So this time I won't write code live because it takes a lot of time. Source code will be published as usually on my GitHub in a form of gist. So let me just explain how this code is working. So on the top you see the isPalindrome method, which is a helper method. I just wrote it to separate the code of checking if string is a palindrome. So this method is using a string and starting with the first character, comparing to the last character, and going to the center in a loop. If all characters are matching, the string is palindrome. That's fairly easy, I believe. And the core of this solution is here, the function called brute force. So as I explained on the whiteboard, we are starting with the first character, and we have nested loops. So thanks to that, we are able to check all possible substrings starting from particular index. And when we create a substring using the indexes from both loops, then we just check if that's a palindrome. If it is a palindrome, we just check if it's longer than the current maximum. At first the maximum is an empty string, that's obvious, and then we just replace it. That's fairly easy solution, very inefficient, but it's working. So maybe run the code with the test case, which is the same as on the whiteboard. And yeah, as you see, I added some console logs, which makes it just easier for you to understand which strings are being checked. So we are checking C, CC, and so on, exactly as on a whiteboard. And you see that also all palindromes are being printed. So the C is palindrome, CC, CC, C, and yeah, we are going through all possible characters. Each time the list of possible substrings is shorter because we are going from the left to the right, so there are less characters. At the end, there's only one character, A, which is also a palindrome, and the final solution is CCC. It's also ABA, but we are only replacing the palindrome if the current result is longer, and ABA is exactly as long as CCC, so there's no point to replace it. Okay, so that was the brute force solution. Let's go to the more optimized one. Okay, so we are back on the whiteboard, and the second solution is much more optimized and is based on the fact that each palindrome has center and mirrors around it. So let me explain you how this works. So in case of string A, B, A, the center is B, and all other characters, in this case only A on the left and A on the right, mirrors around it. And we have to remember that the center doesn't have to contain only one character, because in case of the string Abba, the center may contain two characters. Center contains all the center same characters of the palindrome in this algorithm, and then we can expand it to the left and right, adding any other characters we want, as long as they are mirroring around the center. Of course, in our example, we can have the palindrome which contains only the same characters, so the center is palindrome itself. So okay, let's switch to our test string so you can better understand how this algorithm may work. So at first we are starting with the first character, and we are checking all the following characters to find out if they are the same, and we can expand the center. So in this case, the second character is the same, the third is the same, the next one is A, so it's different. So those three characters create a center. So we have in the first step the center of the palindrome. It contains three characters and it's CCC. And in the next step, we are trying to expand the center, and we are checking the characters on the left and on the right to verify if they mirrors around this center. So in this case, there is no character on the left because that's the beginning of the string, and there's only A on the right, so we cannot expand. So the longest palindrome found in this iteration is CCC. Okay, in the second step, we actually don't have to check and start from the second character, because it won't create the longer center based on the same characters. So we can start from the first character just behind the last center. So in this case, we will start with A, checking the following characters, which is B, so it cannot be, oh sorry, so it cannot be the part of the center, so the center in this iteration is A. And then in the next step we are trying to expand it to the left and right, but on the left we have C, on the right we have B. They are different, so the longest palindrome starting from this position is A. And as previously, we switch to the next character just after the last center. So in this iteration it will be B, and we are checking the following characters if they are the same, but in this case it's A, so it's different. So the center of this palindrome will be B. And as previously, we are trying to grow it to the checking the character on the left and character on the right. In this case, they are the same. So we have the palindrome ABA. Okay, so let's start to expand it further. To the left, we have character C, and on the right, there are no more characters. So the longest palindrome from this position is ABA. And as previously, we switch to the position just after the recently found center. That's the fourth step. It's the character A. We are checking if the next characters are the same. So we are trying to expand the center. There are no other characters, so A is the center, and we are trying to expand it to grow to the left and right. But there's only a character on the left, which is B, and there's no character on the right. So the longest palindrome is A. Okay, so as you see, there are much less steps in this algorithm. It's much more efficient. I hope you understood it. So let's maybe switch to the VS Code. I will show you how it's implemented in JavaScript. Okay, we are now in VS Code. As previously, I won't write code live. I just prepared all the methods, and we will just call them with the same example, with the same test case. The main method is called expand around center solution. That's the name of this algorithm. So starting with the variable start and end, they are the start and end position of currently longest palindrome. So we initialize them with 0. And then we have a loop, which is going through all the characters. There's a skip over here, but I will explain it later. So we are starting with getCenter method, which, as you explained to you on the whiteboard, is checking all the following characters, starting with the provided position, checking if they are the same, and trying to expand the center of the palindrome. Then when we have the center, we are trying to expand around the center, just grow the center palindrome to the left and the right, checking if the characters are matching, so if the palindrome can grow around the found center. And then when we have the result, we are just using the if statement to verify if the currently found palindrome is longer than the current max, and if the current palindrome is longer with the max we found so far, we just replace it. And then there is this step in which we if the center is bigger than one character, we just skip the current start, the next step start position to be just behind the current center. So in this step we are moving the index to the last character of the current center, and in next iteration for loop will add 1, so we will start just behind the end of the center. So maybe let's run the code, so you will see the output from the console, which will help you understand it. So we call the get center for the index 0 because it's CCC. It found a center which starts at 0 position and ends at the position 2. We are then trying to expand, but we cannot. It's the beginning of the string. So that's the current palindrome, starting with the index 0, ending with index 2. And in the next step, we are starting just behind, just after the last center of the palindrome, starting from position 3. That's the character A, so it cannot grow. And then this step is important. We are starting with index 4, which is B, and as you remember, this center is only B, so it cannot grow, but the palindrome can grow itself because it has A on the left, A on the right. We have the palindrome ABA, and that's the end of the string. And then we are checking just the last character, which is just after the center of the previous palindrome, but it's the last character, so it can't grow. And that's it. The longest palindrome is CCC. I hope you enjoyed the video and understood the idea behind both algorithms. If you have any questions, feel free to ask me on Twitter, here in the comments section. And yeah, enjoy the video. The source code will be, of course, provided on the GitHub. The link will be below the video. See you next time. Bye.